Alright guys, let's move on. Before I do quickly, any particular questions or thoughts on that exercise? Okay. So let's have a look at swarms now. Like I mentioned, we can base our models on a pretty kind of uninteresting mesh, and then we can leverage particles to actually bring in some geometric complexity now into our models. So a swarm is basically just a set of arbitrarily located points in the domain. They don't have any connectivity information like a mesh does. It's just points at positions. Like I mentioned, the connectivity, this is one of the issues with the mesh. Every mesh vertex has some sort of, it's connected in some way to its neighbors. Therefore, it becomes a bit heavy-handed when if you want to do any mesh advection, you have to worry about things like, mesh tangling up and remeshing, etc. That's why particle and cell methods are so popular, because the particles are it's pretty natural just to advect them, and then they just move into other elements. We just update which elements they live in. If it's in parallel, sometimes we need to transfer those over to another processor, but it's all pretty straightforward. So your swarms, you will be using them to define your materials usually. You can use them to define anything you want though in Underworld too. You could set up a swarm with a floating point which is directly representing your viscosities. Do whatever you want. You can also just create a bunch of swarms for analytics or just to track motion. So here's a typical swarm. So this is the initial configuration. You can see we've got all particles throughout, right throughout the domain there. These little kind of light color ones, these are the ones that are used dynamically. So they're used to actually define various material properties for your simulations. And then we've got a bunch of lines here. These are just tracer particles that we've added just to allow us, when we want to visualize, to actually see where things are moved and give a better feel for the actual motion in your model domain. So, to create a swarm, first thing you need is a mesh. Right. And then all we do is grab the swarm module, grab a swarm object. What are its options? First of all, it wants a mesh. Particle escape is just a flag. You want to say, like I mentioned before, if you want to move the mesh, you can advect the mesh. If you want to advect the mesh, sometimes you need to let it know that, let the swarm know that if the mesh moves and particles now exist outside the mesh, then they should be killed. And that's what we mentioned, the context with the deform mesh context manager before, and that's one thing that gets triggered here. At the end of your mesh deformation, any particles that are no longer inside the mesh get removed. Right, what's it not happy with here? To mesh, FE mesh. Oh, I forgot to add the actual mesh. Right. It's empty. The swarm object itself is just a container for particles. And you can create as many swarms as you want, and you shouldn't hesitate if you just, if you have certain particles you want for one task, another bunch of particles for another task, just create new swarms for each. You don't need to feel like you need to, shoehorn all your particles into one swarm. And you don't want to do that in instances where you use your swarm dynamically. You don't want to just go and add more particles in, because then potentially they're going to influence the dynamics. The other thing is, well, I'll get to it when we talk about swarm variables. Right, so there are two main ways in which you can add particles to the domain. First method we're going to look at is using layouts. Layouts are objects which just tell the swarm how to populate itself, usually across the entire domain. The other way we're going to look at is where you pass in an array, a NumPy array, which defines particle positions, and then it adds discrete particles in that sense. So let's create a layout object first, right? So layout, and in the swarm module, there's a layouts module, which itself contains basically 4 different layout types. The global space filler layout, it's agnostic to the mesh itself, besides the mesh extent, and it adds particles in a pseudo-random fashion. It aims to add them in a pretty homogeneous sense. So let's give that one a crack first. All it wants to know is how many particles per cell or element. Let's add 20. Right? So once you have a layout object, you need to go ahead and use that layout object. Alright, so you go swarm, and then what do we do here? We add populate. Populate using layout. Alright? Yep.
With this option, then there's a possibility some elements may not contain particles.
No, not because you have to add at least one. This will ensure that you're adding the per element. It counts per element. Oh, sorry, I forgot to add swarm here as well. Swarm, right? So in this case, it will always be at least, well, it will actually give you exactly how many you want per element. Right, so we ask the swarm to populate using the layout object, so we hand in that layout object we've created. And let's have a look at our particle count now. Particle global count. What's it not happy with? Okay, so I executed that cell a second ago, and now I've executed it again. The thing with layout, you can only use a layout object once in any particular swarm. You can't use a new layout. If you need to change the layout, you need to basically just make a new swarm and get rid of the old one, or just leave it, it'll disappear.
Could you add particles later on if you wanted?
You can add particles discretely, yeah, but I don't think it's something you normally want to do.
No, it's not.
Yeah.
We had the case just that someone wanted to do that.
Right. So yeah, typically the layout object is, like I say, just use it when you want to fill the entire domain. And then when you add discrete particles, you normally want to do them in different swarms. There might be some cases where it makes sense, but not usually. Right, let me just to confirm the count. All right, we've got 320 particles now. Note there's also a local count guy. We're operating in serial here. It should be the same number. Okay, so we use the points visualization object now to render that. It wants to know a swarm. There's various options when you're using the points guy. You pass in some function to represent the color. A mask function you can provide, which basically says don't draw some particles and draw other particles, and then you can change a function to define the size of the particles, etc., etc. We're just going to do the vanilla option for now. Right, points are a bit small. Let's grab the WebGL because we can. And we can scale the points sizes up a bit if we want. All right. We have a swarm, it has particles. That's not what I wanted. Let's try again. Okay, so the other option is to create a swarm from an array. Let's create a 3D mesh in this case. Let's call it mesh 3D. Mesh. Let's go 16, 16, 16. Minus 1, 0, and 1, 1, 0. And we'll create a swarm. What am I happy with? Maximum of 2 mesh. Okay. Python's a bit funny sometimes with when you've got named arguments and positional arguments. So let's just be explicit here. Min chord, max chord. Now what's the engine amount? Min chord must be less than max chord. I need to have this as 1. Right. Okay. So we're going to now create an array with a bunch of particles in it. So let's say we want 5,000, right? So, we have number here, math, make sure maths. Right. Let's create an array. And we want it to be count and 3. Right. Define an angular velocity. Um, 10 spirals. Yep.
You have a typo on the first line of port 2 and port 9.
Thank you. Let's just grab a float version of that index. You just have to be careful in Python sometimes when you're mixing float types and integer types, because sometimes it can truncate things when you don't want it to. So it's always better to be explicit when you can. Okay, so on math angle times float and what do we got here? Index float. Right, let's see if that actually worked. So we will, now the method you use once you have your array of particles is the add particles with coordinates method, and we will add that, the argument will be the array we've created. Okay, so I've noted here that when you add these particles, it returns an array, and that the array it returns is actually the index of that particle in the swarm. So, I mean, let's go ahead and add another 5,000. Now you'll see the indices go from 5,000 up to 999. The reason to do that is because often you add particles, but you want to know the index of that particles, you know, because you want to use it in some sense to set data on it or whatever. But if you just add it and it doesn't return the actual index, then you don't have any way of directly finding it. I'll just go and clobber that now. And let's replot those. Okay. I have used the wrong swarm. Let's try that again. Right. And okay, this is WebGL is a bit more useful in this instance. Any questions on that?